Good afternoon. In this video we're going to explore the conveyor belt macros within ZebraCut and the new wizard for creating them. So we're going to go to Rhino and look at the ZebraCut plugin. We're going to go to the Generate tab and you'll see a whole variety of generators for different types of geometry. We're going to look at the modern belt generator here, and then we're going to select a configuration. The white ones are examples, and the orange ones are ones that you have saved as the user. So I'm just going to look at one of the examples. To generate the geometry, we'll just press Generate, and we can see what we're going to appear. So just to orientate ourselves, we've got the cut layer, the cut contour in green with the teeth on the left, and then the corresponding pattern on the right-hand side. Got the fittings down both sides for any sprockets required, and then additional fabrication it would be in pink, and that would generally be on the center of the belt. None on this example. We can also choose to generate various different forms of belt, so we can create a let's do an angled one first. So this is an angled join, and in this case we do have fabrication. We have rectangles of circles on there as well. So that's an angled join. And then finally, in terms of the belt form, we have the circular conveyor belts. And in this case, we have fabrications being lines across the width. Generally, on a circular belt, you'd only have the outer radius having the fittings, which is as you see. So a few new features over the last video that you may have seen. We now have a wizard, so if you choose a configuration and then press the star button, we'll now get this wizard pop up, and this will take you through the interface and all the settings and parameters for creating a belt. You can of course still use the existing generator menu, but it has an awful lot of options. If you know what you're doing, it's great and easy to use. You can find them all very quickly. You can even search for them as required. However, we prefer that you use the wizard because it will walk you through the process step by step. So the first thing we're going to do is set the name of this. This might be the product code and maybe some distinguishing information about the belt. On any page, if I were to leave something blank or put in a bad value, when I try and go to the next page, you'll see I get that there are errors and a message that the name is required. So I'm going to click in here, give it a name or a product code. Any field that I click on, you see I get the instructions about it. I get the same information if I just hover over the entry field. So there's lots of help to help you set the right values for this. But once I've fixed the problem, I can either click to validate, or I can just press next and it validates for me automatically. So the form is the next thing to look at. So once you select a form, the options that you're presented with will change based on the what's required for that form. So for an angled belt, for example, we need to set the angle of the join. Let's say it's 60 degrees. And we've also introduced the ability to have an overlap as well, and that works on all belt forms. So we can have 20 mil overlap if you're not using teeth and you're just overlapping and gluing the belt, or if you want to account for stretch in your material, you could add a couple of millimeters additional length to account for any stretch in the material while it's being cut. So that's our form. You see we've got up and down entry values here as well, if that's helpful. We also have now material belt footing working correctly. We specify the orientation of our belt, and if we want to choose to, we can fit the belt to the material, and that calculates accurately even if you're using a circular belt segment. You can specify the minimum number of pieces in the width and the length. So there's a lot of functionality in there, a lot of flexibility. However, I would say that because we have full industrial nesting within ZebraCut through Magpie Nest, it's not as essential to accurately size your belt to the material. You're of course very welcome to, but the nesting algorithm itself As long as you give it the freedom to freely rotate your belts, I don't think material fitting is quite as necessary. But of course, you can still use it to split long belts into multiple pieces, and indeed you can look at doing circular belts. Circular belts over 360 degrees are always fitted regardless, because you simply can't manufacture more than 360 degrees. So that's belt fitting, or material fitting I should say. Then we go on to the outer teeth. So if you want to use outer teeth, you need to specify the number of them. Again, so one is one at the top, one at the bottom, so essentially two on each side. And you can also select the form of the teeth. We're going to tidy up these images, they're just placeholders for now. Got the width and the length of those. Similar options then for inner teeth. Again, you can choose none and just do an overlap if you wish. And then you've got the control over the width and length of the inner teeth. Fittings, there's a lot more options for fittings. The first one to worry about is the form. We've got none, circles, points, rectangles. And by the way, if you're using a drill tool, I'd recommend you use points because it's a single point for the drill or punch tool. Dashes, lines, slots. Slots can be essentially they're rounded rectangles, and they can be either in the width or the length. Just change the width and length appropriately, so you could have 40 there, or you could have 20 by 40 in the other direction, and you want to change the radius based on how much rounding you want. Obviously, if you set it to 500, it's going to limit it for you to be a maximum radius of 10, because a semicircle of diameter 20 would be the biggest it would fit. So you can always put that to a larger number, and it will just do the largest radius that it can. So once we've chosen our form for our fittings, we're going to look at the spacing. A new option here is whether we're dividing by count or dividing by pitch. I understand if we're doing a circular conveyor belt, we'd almost always be using divide by count. Once you've told it how many holes you want to have, you see you can't enter the pitch because we're on divide by count. And when you press validate, it will validate the pitch for you. If you want to override that, you can of course put it back to divide by pitch, and then you can modify that to be 8.1 if that's what you know it needs to be. Be careful, because it will try and ensure there's a clean pitch division. If you really want to override that, just turn it off. But ideally run with as many of the checks and balances as possible. So up to you on that one. Beyond that, we've got the position of the fittings, top and bottom or both. For circular belts, I can only do the exterior, the outside radius. Whether or not you place the fittings into the teeth, the inset from the edge of the width, the first hole inset, that can be at most one fitting pitch, and it will limit it to that for you. So you may have to do a little bit of math to work that one out, but it should all do. You should be able to achieve the required results. Finally, punching. A lot of options in punching. The key thing here is that we're going to say the number of fittings per punch, including the guides. So that's something that's really important to calculate correctly. And you can see there's some examples on there. For example, a 23mm pitch across 230 millimeters is 12 fittings per punch. And then you've got choice over whether you punch the whole belt, and that includes the join. So you're punching across the teeth join, or whether you're not and just punching across the join. So you've got full options there based on what you want to actually punch. So if you're cutting slots, for example, you might want to cut all of the slots across the belt with the machine, but you might, for example, want to punch across the joint. So there's options there for you, and if you are only punching across the joint, then you can obviously say a much smaller number there, just to work out how many you want to skip, how many fittings you want to skip around the teeth at either end, and that's obviously centered on the leading and trailing edge of the belt. So plenty of options in there to explore. Fabrication, I'm afraid you've got even more options. There's a lot more variation in here. We've added a bunch more options as well. Again, these are just placeholder images for now. We will have proper images of what things are, but a lot of different options, notably including stripes. So we might have 3 bands of holes going along our belt across the width, as it were. Sometimes those are offset, which we call domino. So a domino stripe would be circles that are essentially somewhat nested, like a crate of oranges, for example. So we can choose what we're going to use, and then based on that, we'll get the various margins and widths and pitches that we need to enter to make that work. So it's always going to be a little bit of trial and error. At any point when you're working on your belt settings, you can click to validate in the bottom right hand side, and at any point as well you can also just press generate in ZebraCut, and then you get to see what things look like. So here, for example, I've got my fittings much too big for my pitch, but I can sort that out and then recreate it reasonably. So lots of options. If you do get onto grid circles, which we can see just here in pink, there are a lot more options, and you'll see we get an internal width and length pitch, so internal pitch settings, and that controls how the pitch and the width and the length within this kind of repeated rectangle of circles. So again, the best bet really here is just kind of play with the options and see what each of them do. There's no downside to just creating and hitting generate as many times as you want until you get the result that you're after. So yeah, very much worth exploring. Once you've got everything ready, obviously we're making sure we're validating as we go through to spot any problems. We can kindly go to the generate tab. We can validate, we can save, and we can generate. And generate here just does the same thing as generate up here. But obviously it's really important that we save, give it a name, give it a number, product code, whatever it might be, and then we can finish. I should have said you can always go backwards and forwards in this generator. There's no constraints there, but whenever you leave a page, you must leave it valid. So if I go back to here and I have no name, I can't get out of this. I can't go to a different page until I fix the problem, which is that name is required. So now I can go through and go forward. So that's the belt generator wizard that's been put together. So you can access that for any of the previous configurations you've made. Just press the star button. It's also worth saying that you can now also just open a configuration using the kind of open file dialog. That allows you to save your generator configs anywhere you like, such as on a network drive. If you save them on the network drive, they won't appear automatically in this list, but you'll still be able to open them and then navigate to your network drive and open them up. So with that, I think that's pretty much it for the new features. We've done a lot of work on belt fitting, belt division, the new wizard, a lot of bug fixes, and hopefully it's in a really good state for generating your belts. Any questions, please do get in touch. Thank you.